Hi everybody, happy Pride Month. It's been a very exciting start to this month, and I wanted to take an opportunity to speak with you about how exciting it is that NASA has recently selected 2 missions to return to Venus, a place that NASA has not visited in quite a long time. Venus is the second planet from the Sun, very much similar in size to Earth, but also very different. Shrouded in a thick carbon dioxide atmosphere, makes its surface nearly 500 degrees Celsius, and the surface pressure is about 90 times that of Earth's surface. So it's like being at the bottom of the ocean. So a pretty hellish place. Sulfuric acid droplets in the air, and shrouded by this thick veil of clouds that makes it impossible to see the surface clearly. But it is shaping up to be the decade of Venus because, well, we'll get to that. We'll get to that. What we have done, we've been to Venus, is, there we go. We had a number of flybys in the 70s. The Soviets sent the Venera probes in the early 80s. Some of these actually did descend to the surface and took images. A few of those came back along with some pressure and temperature and composition data. Tough little buggers, but they still only lasted a couple of hours at best on the surface, sending back these images. The Japanese Space Agency had an orbiter called Akatsuki, which had a very interesting tale. It actually missed Venus the first time around when it was launched in 2010. But through some very clever engineering, they were able to come back later, and since about 2015, it's been making atmospheric observations of the planet in this long looping orbit. And NASA's last visit was with Magellan, launched in 1989 from the space shuttle. Magellan orbited Venus, taking various measurements, a lot of radar images. You may have seen these very famous, vertically stretched renderings of the surface of Venus in this, appropriately hot and hellish color palette. But that's the last we have. That's the last information that we really have from Venus, and we've learned a lot from that data, from other flyby missions, from planetary geology in general. And we are now equipped to go back and really ask the specific probing questions that will answer some of the things we don't understand about planetary evolution and why Earth and Venus ended up so different from one another. Distances to the Sun notwithstanding, there's still a lot of reasons why Earth and Venus are dissimilar. And why is that? And what does that mean for life around other stars as we begin to discover more and more planets? So just this past week, the new NASA administrator announced that NASA's most recent Discovery program, which is a cost cap program that solicits competitive mission proposals, very much like InSight, to provide proposals for a complete science mission under a certain cost cap. And to many people's delight and surprise, they picked 2 missions, both of which are going to Venus. DaVinci Plus is an atmospheric probe. I don't know terribly much about it, but it will descend through the atmosphere and presumably make it to the surface, sending back measurements, including things like isotopic measurements, which will tell us a lot about the history of water on Venus. And then there's VERITAS. DaVinci Plus is from the Applied Physics Laboratory, Johns Hopkins, sort of the East Coast cousin of JPL. And JPL's mission is VERITAS. Which I was part of. I was involved in VERITAS for their second round of proposals, and then the site visit with NASA, which is a big deal. And we were all biting our nails, waiting for the NASA budget to come out and for them to announce who won. Was it one of the 2 Venus missions, the mission to Io, or another JPL mission to Neptune? The Io and Neptune missions were not selected. This was their first time through the Discovery process, and no doubt, and I hope that they will propose again. But for the future, we have the decade of Venus before us. I'm so excited also because The principal investigator of VERITAS is a friend and colleague of mine, Sue Smirkar. She is the deputy PI on InSight and is one of the world's foremost experts on Venus. She has loved and studied Venus for decades and has been part of teams that have proved the existence of recent volcanism on Venus. Recent, of course, in geologic terms, a few tens to millions of years ago. But there's reason to suspect that there might be active volcanism on Venus today, and that's something that VERITAS should be able to see, and that's really cool. And so I am so thrilled for Sue and for everyone else on the team, all the other scientists and the engineers. Working with them has been a great pleasure. It's a small team and very tight-knit, very smoothly running, and very kind, and just they have a nice family bond, very much like we had on InSight, I think. And Sue is a wonderful leader, and I'm thrilled to have been asked to work on the VERITAS project, and look forward to being involved with it as it goes forward. So what is VERITAS? What is it going to do? VERITAS is an orbiter, and once it arrives at Venus, it will orbit Venus for a number of years, taking radar measurements and spectrometer measurements of the surface. It's solar powered. You see the big solar panel wings here, and it actually has extra extenders on it so that it can do aero braking, aero capture, and use Venus's atmosphere to help it survive, or to make the trip with less fuel and get into orbit around Venus with by carrying less fuel with it. Then it has a radar instrument, this sort of double H-shaped thing here. These are the radar antennas of the VISAR instrument, which, among other things, will very accurately measure topography. And then there's also the VEM instruments, spectrometers, that are specifically designed to look through the Venus atmosphere as best we can. Ultimately, you're limited by the size of the cloud particles, and everything's a bit hazy, but you can still get much better images and of a certain resolution, and tell a lot about the composition of the surface. Magellan got topographic data. This is a topographic map of Venus, but at this scale, this is a planet. So at this scale, like the big island of Hawaii would be a pixelated mess. And what we'll be able to get with VISAR is so much finer. And because it will pass over the same area of ground, and it is so precise, we might actually see deformation of the surface as new lava flows are in place, or tectonic forces bulge and sink as parts of the surface. So that's really cool. And the other thing that we can do with them is to look at these different regions. You see that there are some blocks that are like very high altitude. It's like if you look at the topographic map of the Earth and you see the Himalayas sticking up above India so high. There are definite provinces on Venus that are uplifted compared to everything else. And that kind of hints at plate tectonics, that maybe plate tectonics got started at some point on Venus and then stopped. And plate tectonics, it evolved a lot of different rock types on Earth. Rocks like granite have been processed deep in the Earth and brought back up to the surface, and plate tectonics is the engine that allows that to happen. And plate tectonics also recycles things like carbon dioxide in the atmosphere, and it may be a very important thing for maintaining a stable, habitable biosphere. And if plate tectonics grinds to a halt and you're no longer recycling that carbon dioxide, maybe that leads to a buildup of a big, thick CO2 atmosphere as the volcanoes continue to spew it out and covers up Venus, and you end up with this runaway greenhouse effect. All excellent questions, and how do we answer them? Well, one of the things we want to do with the VEM instrument, the spectrometer, is look at these provinces and see, are the rock types there granitic? Does it look like an evolved rock that doesn't have a lot of iron or magnesium in it, compared to lower regions which may be more like basalt, like ocean crust on Earth that has a lot of iron and magnesium? we're not going to get precise mineralogies necessarily, but to be able to distinguish those two major factors and see if there's a correlation in these altitude regions and rock type is just that's how we answer one of these big questions about, did Venus have plate tectonics and what does that mean? As I mentioned before, the particles in the clouds prevent you from seeing things very precisely, but volcanoes are hot, even compared to the surface of Venus, which is really hot. So if you're looking at the cloud tops from above and there's a volcano underneath, we'll be able to see that glow. Just like happened in Iceland when the Geldingsadalur volcano, it's a small volcano, it's a tiny little thing, tiny little fissures and tiny little cones, but it lights up the sky beautifully, and that's exactly the sort of thing that's large enough for the VEM instruments on VERITAS to see. So there's also been some really cool things with InSight this week, and maybe I'll talk about that later, but I just wanted to, to talk about how excited I am for VERITAS. I'm excited for everyone on the team. I'm excited for everyone on DaVinci Plus, and I think that it's going to be a fantastic experience for me, for everyone on the team, and the science we're going to get out of it is going to be incredible. So go VERITAS, and thank you, NASA, for making it the decade of Venus.